Hello everyone. Now this is our third session. इससे पहले we have already completed two chapters. The first chapter is for sure it's the introduction where we discussed about the how do we read the science. Okay, the basic introduction. Next one we discussed about the electricity chapter. Okay, and here we are with the third session and another chapter which is heat. Okay, now in this chapter basically we will try to understand how heat is related to our day-to-day life phenomena. There's a lot of things that you let's say when you keep the ice for some time, it converts to water. Why does it happen? Or when you boil the water again, it converts to water vapor. How is that happening? How do you feel cold? How do you feel hot? Why do you wear woolen clothes in winter? Why do you wear cotton clothes in summer? Also, we prefer to wear dark clothes in winter season and light clothes in the light color clothes in the summer season. Why it is happening? Or let's say you keep some hot water in the thermos flask. Okay, so why that thermos flask in that the water in that thermos flask remain hot for longer time, like for 15 hours, 20 hours. But at the same time, if you keep a mug of water full of a mug full of coffee mug, which is hot, if you keep it within 10 minutes, it will become cold. Okay, so how it is becoming cold, where that energy is going, where that heat is going. So that all thing we will try to understand in this chapter. Also, we'll try to understand whether heat and temperature are the same thing, right? Are the same thing? If they are not, what is the difference between them? So that all of them we will try to understand in this chapter. Fine. Let us start our discussion with understanding what is heat exactly. Okay, what is heat exactly? So heat is nothing but it is a form of energy. Okay, shall I write it down? Okay, I'll just write down everything. Okay, so talking about the heat. Okay, first and foremost thing, it is a form of energy. Form of energy. Acha, again I'm saying, don't worry about the notes, everything by bullet points and in the elaborated notes. Even if you want, I can share this slide with you. So nothing to worry about the notes, everything notes you will get. If you wish to write down, you can write from here also. So I'm just writing it out. So heat is basically first and foremost thing, it is a form of energy. Okay, what form of energy? Which provides or causes the sensation of hotness or coldness. You can write from here also. It is a form of energy that causes the sensation of hotness or coldness. Okay. Acha, what is temperature? What is thermometer? We'll come upon that. First, let us talk about the heat. Acha, how do we call something as energy when it satisfies basically the two conditions? First thing, it is capable of doing some work and it is interconvertible to another form of energy. Okay, so heat is basically having capability of doing work and it is interconvertible to another form of energy. Okay, did I do some mistake? Wait, just a second. There something happened. I'll have to go back. Just wait a second. Okay, fine. Now, so heat we call it as energy because it is capable of doing some work and it is interconvertible. Clear? This is clear. Also, when we talk about the heat, we can let us change the color. Okay, let us when we talk about the heat, it can be transferred from one body to another. It can be transferred from transferred from one body to another. Okay, from which body to which body? That is also a question. From which body to which body? So it can be transferred from a body of higher temperature to a body of lower temperature. I'll just quickly write it down. I'll just write it down. So it can be transferred from a body of higher temperature to lower temperature. Now, what is the temperature term? What is the temperature term? Let us try to understand that one. Okay. Now, let us next talk about the temperature. I'm removing this one. Fine. Okay, now let us talk about the temperature. What is temperature? So temperature is basically the measure of the how hot or cold an object is. Okay, it measures exactly how much hot or cold an object is. That is measured by the temperature. Acha, if we talk about the units of temperature, so generally it is measured in three main units. First one is the Celsius, written as degree C. Next one is the Fahrenheit, which is degree F, and last one is the Kelvin, Kelvin, which is denoted by K. Acha. Kelvin is the SI unit of measuring the temperature. That is the SI unit of temperature. Okay. Acha, one important thing, heat, as I say, it is the flow of energy. flow of energy. Okay, from a region of higher temperature to lower temperature. And temperature basically gives the idea that from where the heat will flow, from where to where the heat will flow. As I told you, heat always flow from region of higher to lower temperature. Okay, see here temperature term is there. It flows from region of higher temperature to lower temperature. So first you need to know that what is the temperature of two different bodies, then only you can say from where it is flowing. Is that clear? Is that clear? Clear? Acha, about this Celsius, Fahrenheit, and Kelvin, how we can convert Celsius to Fahrenheit, Fahrenheit to Kelvin, Kelvin to Celsius, and how we can convert the values interconvertible. The values are interconvertible between Celsius, Fahrenheit, and Kelvin. So that we will see later on. But first of all, let us talk about what is the difference that we have discussed so far. I'm removing this one, fine. So let us discuss what all the difference we have discussed so far about the heat and temperature. I'm writing in short. This is temperature. Okay, I'll write down heat and temperature. Okay, so heat we understood it is a form of energy. It is a form of energy. Okay, talking about the temperature, it is the measure of hotness or coldness of any body. Okay, I'm writing in short. Talking about its SI unit of heat is joule. Joule, which is denoted by J, since it is an energy, that's why it is measured in joule. Talking about the SI unit of temperature, it is Kelvin. Kelvin denoted by K. Clear? Now, next one, talking about the heat basically flows from a region of it flows from a region of higher temperature. Basically, you can tell that heat is a flow of energy. Okay, in short, let me write down in short. Heat indicates heat is basically the flow of energy. Flow of energy. Why? If I talk about the temperature, it indicates in which direction, it determines the direction in which direction the heat will flow. Heat will flow. So it talks about the direction in which heat can flow. So these are the overall these are the differences between heat and the temperature. By now I hope that you are clear with heat and temperature. Okay, if you're clear, then we can go to the thermometers. Okay, next one, thermometers. Let me remove this one. Okay, so next one, we'll be talking about the thermometers. Okay, what are thermometers? So let us start with the definition. Thermometer is basically an instrument that is used to measure the temperature. Acha. First thing that comes to my mind generally, why do we need temperature? Why do we need the thermometers? अच्छा, अगर मैं बात करूं, let's say if a body is hot or cold, generally start with, अगर हम बात करें हीट की, हीट इज अ फॉर्म ऑफ एनर्जी, और बात करें अगर टेम्परेचर की, टेम्परेचर मेजर करता है हाउ मच हीट और कोल्ड दैट ऑब्जेक्ट इज, एंड टेम्परेचर ये मेजर किस चीज से करता है? थर्मोमीटर से. ठीक है. सो डू वी नीड थर्मोमीटर टू मेजर द टेम्परेचर? ओके, क्या हम कांट वी डू इट विथ आवर हैंड? कांट वी यूज आवर सेंसेस? कांट वी यूज आवर सेंसेस? Can't we use our senses? Can't we touch any object and tell whether that object is hot or cold? Sometimes, up to some extent, we can say, but not always. Like we cannot rely on it. Okay, for that one, I would like to give you an activity. Let's say I take a glass of water. Okay, let's say I take three beaker. Okay, let's say this is beaker A, this is beaker B, and this is beaker C. Let's say this is filled with the hot water kept at, let's say, 70 degrees Celsius. Okay, and this one is filled with cold water, let's say 2 degrees Celsius. Okay, and in this one there is another sample of water which is kept at 25 degrees Celsius. Fine. Okay, now let's say this is your left hand. I'm not so good at drawing, so don't expect me to draw the hand for you. Okay, so let's say this is your left hand or right hand. Okay, anything we can take. This is left hand, this is your right hand. Okay, so at once you put your left hand in this beaker A. Okay, and your right hand in the beaker C. What you will feel on the left hand, you will feel that the water is hot. Clear? Good thing. On the right hand, what you will feel? You will feel that the water is cold. That is also correct. Now what you do, you take that left hand, same left hand, and put it here. Okay, and take that right hand, put it here. Okay, so now what you are doing, both your left hand and the right hand are there in the same container which is having water at temperature 25 degrees Celsius. Clear? Now, what will happen? What you will feel on your left hand? What you will feel on your left hand? Your left hand will feel cold because earlier your left hand was in the more temperature. That's why your senses will say that this water is cold. Okay. What your right hand says, since it was at 2 degrees Celsius, now you are putting at 25 degrees Celsius. So now your right hand will say that the water is hot. Hot. So which one you will you believe? Both are your hands only. Both are your hands only. One of your hand is saying that the water is hot. One of your hand is saying that the water is cold. Which one do you believe now? Okay, that's a big question, right? So that's why we cannot rely on this method. We cannot rely on our senses to see or to measure the temperature of any object. It just our senses can just tell the comparative difference in the temperature, comparative to that one, compared to 70 degrees Celsius, 25 degrees Celsius is cold. That's why I'm feeling cold. Clear? Clear, I guess. This much is fine. So shall I remove this one? Okay. So next one, talking about the temperature. Okay. So one more problem with our sense is that it cannot measure exact value. Okay. It cannot measure the exact value. It cannot, I just write down, it cannot measure the exact value, exact temperature. That's why we started using the thermometers. Thermometers. Okay. Now, in this section, we'll talk about the thermometers. So there are different types of thermometers that we will cover in this section. The first one talking about the mercury thermometer, then we'll talk about the digital thermometer. Next one we'll talk in detail about the clinical thermometer. Okay. Clinical thermometer only, mercury thermometer and the digital thermometer both are called as the clinical thermometer. What are the working of that? We'll discuss that. And next one we'll talk about the laboratory thermometers. Okay. Let us start with the understanding of what you call it as a ideal thermometer. What you call as a ideal thermometer. What do you think, like which thermometer is like good one? How do you categorize it? Okay, so let us talk about the qualities, some of the qualities of an ideal thermometer. Ideal thermometer. So the first one, thermometer wall should be thin. Okay, thermometer wall should be thin. Should be thin. First one. Second one, this capillary must be narrow. Just keep these words in your mind as of now. When I will discuss this one, when I will discuss this one, I'll tell you this is called actually the capillary tube. Okay, I'll talk about that. No worries. Acha. In the starting, I'm removing this one. In the starting, in the old time, we started using the mercury thermometer. Mercury thermometer. Now, why we are using the mercury thermometer? Is there any benefit? That's why we are trying to use the mercury thermometer. So yeah, yes, there are some of the advantages of mercury as a metal. That's why we are using the mercury thermometer. What are the advantages? Okay, so I'll just write down some of them in summary. Its expansion is uniform. Its expansion is uniform. Uniform means with a equal amount of increase in the temperature, it rises equally. Okay, it's not like if you increase by 2 degree, there's some different expansion. If you increase by some another degree, there are some different expansion. So it's not like that. That's why we use this one. Okay, next one, it is a good conductor of it. It is a good conductor conductor of heat, means it conducts the heat and helps it to expand. Okay, third one, it is opaque. It is opaque due to which you can see the reading. If you can see here, see, you can clearly see the reading is here. Okay, why? Because the mercury is opaque, it's not transparent, so that you can see where is the mercury level. Clearly you can see the mercury level. Next one, it does not wet the glass. It does not wet the glass. What does it mean? Let's say here, if you see here, if the mercury rises up to this level and when it comes down, the none of the capillary tube is wet by the Hg. Hg means the mercury. Mercury does not remain there. Every molecule of the mercury comes back to the this cylindrical bulb again. Okay, so it does not wet the glass. Clear? What other things which is good for using the mercury thermometer? It is easily available. easily available in pure form. In pure form. Fine. It is easily available. And next one, it is high boiling point and low melting point. Okay, it has, I'll just write it down. High, I'm writing BP in short, boiling point, and low melting point means if you are using mercury and let's say you put it into water which is boiling, you want to measure the temperature of boiling water which is around 100 degrees Celsius. So that time if the mercury itself starts boiling, then it cannot give you the measurement correctly, no? So that is also a good point for for using mercury as a thermometer. Okay, mercury in the thermometer. Acha, if this is all good, why we replaced it then? So for sure there will be some problems also. So let us talk about some of the disadvantages. Disadvantages. What are the disadvantages of using the mercury thermometer? First one, it does not record the small value. It does not record the smaller values. Like in the points, it cannot go in very points. The small change in the temperature, it cannot record. Okay, very low temperature, it cannot record. Okay, also it is difficult to decompose once broken. Okay, third one, since it is made up of glass, it is highly uh, high care is needed. Okay, the mercury which is used in that bulb is poisonous. It is poisonous and it do not decompose easily. That's why these mercury thermometers are not suitable for taking them. We cannot say it is a suitable, but nowadays it is replaced with the digital thermometers. Okay, so why we are using the digital thermometers now, you can understand, I guess. Okay, you can understand, I guess. Clear. Now, let us talk about the thermometer cut from here. Tree thermometer. Then further, we'll talk about the the relation between Celsius, Fahrenheit, and the Kelvin. Okay, let's start with the clinical thermometer. Okay, so clinically thermometer, in this one we use two thermometers. First one, as I told you, we use the mercury thermometer, and the second one we use the digital thermometer. Why we use the digital thermometer? Because it is more accurate, easy to handle. Okay, it is easy to handle, and also it does not require use of mercury or something. Because of it, it is safe to use. Okay, it is safe to use. That's why we use the digital thermometer nowadays more. It can just work on the batteries and it is safe basically. Also it can measure the a smaller temperature, a smaller rise in the temperature, it can measure in points, so that is also a good use. Now, talking about clinical thermometer. Okay, so clinical thermometer, first of all, it is basically, it looks like this one. I'll just mention the names here. First of all, if you see the outer layer, it is called as the glass case, and inside there is a tube, open tube, that is called as the capillary. There is a cylindrical bulb in which this one mercury is filled, and there is a kink. Kink is very important. Kink is basically very crucial and a deliberate constriction just above the bulb. What does it do when the mercury rises up in the thermometer? Okay, so there is a tendency for this mercury to come down. Why? Because of the gravitational force acting on it. Because of that gravitational force, it try to come downwards. Okay, to stop that, okay, to prevent that, this kink is the kink shape structure is installed there, so that the mercury level does not go down because of gravity. Okay, because of gravity, it does not go down. Clear? Okay. Now, while you take the reading, okay, so in that one, its range is almost from 35 degrees Celsius to 43 degrees Celsius, which is in Fahrenheit, 95 degree Fahrenheit to 110 degree Fahrenheit. Okay, if you see here, this is a death occur because the normal body temperature, if it drops below 95 degree Fahrenheit, that's a critical temperature. If it is more than 110 degree Fahrenheit, that's absolutely critical temperature. The person will die because of the organ failure. Okay, since the clinical thermometers are used for measuring the body temperature only, that's why its range is not much. Its range is 35 degrees Celsius to 43 degrees Celsius. That's more than enough. Clear? Acha. While you see the reading in the mercury, so make sure you see the line exactly from here on the top. You should not make any parallax error. You should not make any parallax error. Okay. Once you are done, we use the thermometer. So what you have to do, you have to wash with the water. Okay. If And after that you jerk firmly, slowly. Okay. You jerk it so that this mercury level again settle down to this cylindrical bulb. Okay. So that you can use it again later. Clear? While doing this, you have to be very careful, because if you leave it, this is made up of glass, it will break. Okay. So that you have to take care of. Now, next one, talking about the laboratory thermometer. Acha, why do we need the laboratory thermometer? Why do we need the laboratory thermometer? Reason is, when I was talking about the clinical thermometer, so the range of clinical thermometer is just from 35 degrees Celsius to 43 degrees Celsius. But in the labs, when we are doing experiment and all those things, so we have to measure various temperature. Okay, so that's why laboratory thermometer generally ranges from minus 10 degrees Celsius to 110 degrees Celsius. In the labs, there can be other kinds of thermometers also, whose range can vary, whose range can go up to 150, 160 degrees Celsius also. So that much also. But generally, if they ask what is the range of laboratory thermometer, so it is from minus 10 degrees Celsius to 110 degrees Celsius. Okay. Acha, in the laboratory thermometer, there is no kink. Okay. So whenever you are measuring, so at that instant only you have to measure. Let's say this water temperature you have to take. So you have to put it inside the water, and at the same time you have to see the level of the mercury. Okay. Once you take it outside, the level of mercury will drop. Okay, for sure it will drop. Okay, so you have to take at that time also. That time only. Also, you do not see the position how you are keeping the thermometer. Your thermometer should always be upright. Okay, it will be straight. It is upright. You don't keep it tilted, or else you'll not get the exact value. Okay, now that next one, this bulb, which is measuring the temperature, it should not touch here. It should not touch here. It must be there above the surface. Okay, it must be above the surface. So basically, at the real time, you can measure the temperature. If you take it outside, the temperature may increase, temperature may decrease. So you have to take it at the real time. Okay, it is used in the labs. It is used to measure the room temperatures, and there's a lot more uses are there. Okay, now next one, let us talk about the two scales of temperature. In the first one, which is the Celsius scale, and next one is the Fahrenheit scale. Talking about the Celsius scale, so it was introduced by Swedish astronomer whose name is actually Celsius. In his honor, this unit name is given. Same was with the Fahrenheit also. Fahrenheit introduced a smaller scale. Acha, Celsius is a little bigger scale. Fahrenheit is a smaller scale. That's why if you see, 35 degrees Celsius. Did you see here? 35 degrees Celsius is started with 95 degree Fahrenheit. So because Celsius is a bigger unit, Fahrenheit is a smaller unit. Okay, talking about the base unit, so Celsius scale start with 0 degrees Celsius, go up to 100 degrees Celsius. Acha, this 0 degrees Celsius is the ice point, and 100 degrees Celsius is the steam point. Means if you touch that, thermometer at ice, it will show 0 degrees Celsius. In the boiling water, it will show 100 degrees Celsius. Same, the ice temperature in the Fahrenheit scale is 32 degree Fahrenheit, and in the boiling water it is 212 degree Fahrenheit. Okay, clear? Okay, in the Celsius scale, if you see, so there are a total of 100 equal division between 0 degree to 100 degrees Celsius. In here, between minus 32 degree Fahrenheit to 180 degree Fahrenheit, no, no, 100, no, 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 212, 212 degree Fahrenheit, there are, let me do 32 degree Fahrenheit to 212 degree Fahrenheit, there are 180 divisions. Very often, this question, like how many divisions are there, is being asked in the exams, in the MCQ type questions. Okay, so you understand now what is the difference between Celsius and the Fahrenheit scale? There's a diagram here. You can check it out. Okay, I hope it's clear. There's nothing else. Achha, talking about the relation between this one, what I will do, let us talk at the same time. Let us talk about the Kelvin scale, and at once I'll give you the whole relation. Okay, so let us talk about the Kelvin scale. Now, Kelvin scale is quite interesting and more important also, because Kelvin scale is the SI unit. First, I'll tell you it is the SI unit of measuring the temperature. Okay, so here the things are little different. At 0 degrees Celsius, in Kelvin scale, it is 273.15 Kelvin. Okay. At the same time, in the Fahrenheit, we are not talking about this one as of now, but for the comparison, you can see this diagram will help you. At 0 degrees Celsius, the temperature is 273.15 Kelvin. At 100 degrees Celsius, it is exactly 373.15 Kelvin. So what you see from here, there is a rule of equal steps. Like if you increase 1 degree Celsius, so it becomes 274.15 Kelvin. In junior classes, you can just ignore this point values, the values after decimal. You can just say 273, 274, and so on. But exactly it is 273.15, it is 273, 274. Similarly, if I say 27 degrees Celsius, so it will be what? 273 plus 27, which is 300.15 Kelvin. So equally it increases. If you increase by 1 degree Celsius, so Kelvin scale also it will increase by 1 Kelvin. Okay, so in the same fashion, it increases and decreases as well. Okay, next one, in the Kelvin scale, you don't see any degree symbol. It is just written K. It is not degree K. Okay, and in Kelvin, you will never see somewhere written like -4 Kelvin. That's not possible. Minimum it can go is 0 Kelvin. That is also an ideal case. That is not possible. That is an ideal case. It is assumed, or it is actually said that I don't need to say it is said that actually it is proved that if somehow the temperature of the universe becomes 0 Kelvin, everything will stop. Everything means all the activities, all the cellular activities, all the chemical activities, all the fundamental. Basically, this whole universe will stop. Okay, so generally it is not possible to get to this exactly 0 Kelvin, but it is said that this 0 Kelvin is the absolute temperature. Absolute temperature means no temperature can be measured below 0 Kelvin. Okay, but in degrees Celsius and the Fahrenheit, you can see you have seen the temperature like -70 degrees Celsius. That's possible. -200 degrees Celsius, that is possible. But you cannot say -5 Kelvin or -17 Kelvin. That is not possible because the minimum temperature in the Kelvin scale that you can go is a 0 Kelvin. Okay, I hope it's clear. I hope it's clear. Okay, and this is the basically the SI unit of the temperature. Here is the formula. Okay, TC means the temperature in Celsius. Okay, I'll just write it down in the next slide. So generally, we are having Tc by 5 equals to Tf minus 32 by 9 is equals to it was to no Tk minus 273, Tk minus 273 by 5. Acha, I'll just write it down quickly. This Tc is the temperature in Celsius. Okay, similarly, this temperature will be temperature in Fahrenheit, and this is temperature in Kelvin. Okay, so this is the interconversion. I'll write down again. You also try to write down this again and again so that you don't get stuck in the numericals. -32 by 9, which is equals to T times Tk minus 273 by 5. This is the relation which connects the temperature in the Celsius scale, Fahrenheit scale, and the Kelvin scale. Is that clear? Clear? Okay, now if this is clear, I guess we can do some questions. Okay, let us try to do some questions. Okay, I'll just remove these things. Okay, now I'll just give you some random 2 3 problems. Let's say I'm taking randomly like 47 degrees Celsius. Let us convert this into degree Fahrenheit. Randomly I can do. So what I'll do, I'll get some value in the decimal values. That's quite possible, but nothing to worry. So I can use the formula TF minus 32 by 9. Now my Celsius is given, which is the 47 divided by 5, which is equals to TF minus 32 by 9. When I solve this one, I will get 5 9s are 45, 220, 5 4 the 20. I guess that's clear. Okay, which is equals to TF minus 32 by 9. If I solve it further, this 9 will go multiply here. So 9.4 into 9. So it will be 9 4 the 36, 3, 9 9 the 81, 84, so 84.6. So this is 84.6 equals to TF minus 32. So this minus sign will go here and will be added here. So TF will be 84.6 plus 32, which is equals to 4 plus 2 6, 8 plus 3 11.6. So this much degree Fahrenheit. This is your answer. Clear? Same way, let us try to do another problem. Let us try to do another problem. Was that clear? That was clear now? Okay. Now let us now convert degree Fahrenheit into Celsius. Okay, so let us take. I'd like to take let's anything. Let's say 162 degree Fahrenheit, and I'm convert to degree Celsius. Acha, in the exams, you can expect questions to be Fahrenheit to Celsius, Celsius to Fahrenheit. This kind of questions will come. Okay. Now talking about I'll again use the same formula Tc by 5, which is equals to Tf minus 32 by 9. Now Tc is not given 5, Tf is given as 162 minus 32 divided by 9. which is equals to Tc by 5, which is equals to 162 minus 32 is 130, I guess, 130 by 9. So I can do it. Tc is equals to 130 into 5 divided by 9. So I can cancel it out. 9 ones are 9, 4 40, 9 threes are 27, 9 fours are 36, 36, 4, 14.44 it will come. You just check the calculations, you do it again, okay, and just try to verify my calculation again. So it will come out to be 14.4 into 5, you multiply it, whatever it comes, that much degrees Celsius, that's your answer. Okay, 5 for the 20 and 5 for the 22. 5 ones are 5, so answer will come out to be almost 52 degrees Celsius. You check the calculations again. Calculations can be wrong, so you need to verify it by yourself again. Okay, okay. Acha, talking about let's say I have to convert degrees Celsius to Fahrenheit, so that's quite easy. That's quite easy. Let's say 25 degrees Celsius I have to convert to Kelvin. Okay, I have to convert to Kelvin. So what I will do, again I will use the same formula. So what I will do, this is Tc by 5 equals to Tk minus 273 by 5. So this is, there's no use of this one. So Tc plus 273 is equals to Tk. Tc means temperature in Celsius, Tk is temperature in Kelvin. Okay, so whatever is the temperature in Celsius, you just add 273. Acha, why I'm using 273 only? In the junior classes, we just take 273. In higher classes, when you'll go. So for now, you can ignore. I know that it is 273.15, but this decimal values you can ignore as of now. You are in the learning phase now, so nothing to worry about that. So Tc plus 273. My Tc is 25 plus 273. So your answer will be 298 Kelvin. That's how you convert Celsius to Kelvin. Acha, if any value is given in Kelvin, let's say 303 Kelvin. So what you do, you just subtract 273 from this one. You will get that value. So 30, I guess, yeah, 30 degrees Celsius. You will get your answer. Acha, if anything is given in degree Fahrenheit, so what you do, first you convert that into degrees Celsius, then you take it to the Kelvin. Okay. Or if there is a question like convert Kelvin to Fahrenheit, so first you convert Kelvin to degrees Celsius. Okay, that's easiest step, right? Kelvin minus 273 gives you the Celsius. Then you convert to Fahrenheit. Generally, these questions are very less. Okay, if they ask you, so mostly they ask the interconversion between degree Fahrenheit and degree Celsius. Okay, there's a lot more questions that can be done on this topic. Okay, if needed, I can make a separate lecture on that, or else you can get a lot of questions there's on the internet, or you can try to take the random values by yourself. Okay, you just take the random values by yourself and try to do it by yourself. Okay, apply the formula and try to do it. You will find out that for any value you can convert degrees Celsius to Fahrenheit, Fahrenheit to degrees Celsius, and subsequently into Kelvin also. That is possible. Clear? I hope it is clear till here. Now we are moving to another form of energy. Acha, before moving to that, let us talk about somewhat about the units of the heat. So as I told you, it is measured in joule, which is the SI unit, but it is also measured in another units that's called as the calorie. Generally, 1 calorie is equals to 4.186 joule. 1 kilocalorie will be the 1,000 times of that one. So 1 kilocalorie is the 1,000 calories. What is calorie? Calorie is basically the exact amount of heat needed to raise the temperature of 1 gram of pure water exactly by 1 degree Celsius. ठीक है, इसके बारे में in the further classes you will learn again. For now, you just try to understand. 1 calorie is basically the amount of heat, amount of energy that you require to reach the temperature of 1 gram. You take 1 gram of water, increase its temperature by 1 degree Celsius. So to increase the temperature of water, 1 gram of pure water by 1 degree Celsius, you'll have to apply some energy. How much energy you have applied, that is only called as the 1 calorie. Okay, is that clear? Is that clear? Why we are taking the pure water? Because if you are not taking the pure water, this value may vary. This value may increase or decrease. That's why we are taking the pure water. Okay, if we take the impure water, this calorie value will come something different. Clear? Clear? So this was a interconvertible. Joules and calories are interconvertible using this formula. 1 calorie is basically equals to 4.186 joule. Clear? Clear? Generally, in day-to-day life, we use the joule. We don't use calorie much. Okay. Chalo. Now we are into the another section where we will talk about this is going to be the important one. When we talk about the flow of heat, which is from higher temperature to lower temperature. Okay. So what are the methods in which the heat can flow from one body to another body? Okay. So we are gonna read about them. Acha. As I told you, heat always from the region of higher temperature to lower temperature until up to what? Until and unless they got the equal temperature on both the bodies. Okay, this is the finish line when the both the bodies get the equal temperature. Let's say one body is at 20 degrees Celsius, one body is at 10 degrees Celsius. When they come in contact, both will the heat flow will stop and both body will acquire 15 degrees Celsius. Okay, so that's the rule behind the flow of heat in the bodies. Now, how does this flow of heat occur? That we will try to understand. So basically, we are having three ways in which the heat can be transferred. First one is the conduction, second one is the convection, and the third one is the radiation. We'll read about this one by one. Okay, so let us first try to start our discussion with the conduction. Talking about the conduction, which is also called the pass it on method. In conduction, what happens? The heat basically transfers in the solid from one hotter end to the another end. Acha. Before that, I would like to let us do one activity. If you take a candle and try to start heating this part of the rod, since it is a metal, the heat will transfer from this side, and these nails are attached with the help of wax. So when the wax got heat, it melts and the pin will come down. Okay, so you will observe that this pin will fall first, this second, this is third, this is fourth. At the last, the pin 4 will drop. It means that what is happening, actually the heat is flowing from here and going towards this side. Again, this proves our understanding. When I say that the heat flows from region of higher temperature to lower temperature, this proves that here is the higher temperature, and this suddenly it is increasing the temperature. This side it is moving towards the colder side, and this is the significance that because of heat the wax is melting and the pin is falling. Okay, it is basically in this method there's no movement of particle. Okay, particle do not leave their original their position. What happens when you heat the any object? So at intermolecular level, this starts vibrating fastly. It starts vibrating fastly. It makes this one vibrate, this one make this one vibrate, and so on. It just keep on going. It just vibrate each other. Okay, and the vibration is passed on to another molecule. Okay, but this molecule remain at this place only, this molecule remain at this place only. This molecule will not go here. Let's say the molecule which was used here, let's say the molecule here, it will never go here. Okay, in the conduction there is no transfer of particles from one place to another. Okay, the particles remain at their place. Okay, for the conduction, one more thing is very important. The body must be in direct contact. The most body must be in direct contact. The heat is exactly here. So heat, we are trying to increase the temperature here. So this will get heated only when this is in contact. Here also the metal is there, but it is not getting heated. Acha, it is getting heated because of another thing that we will read further in this section. But because of conduction, it is not heating because they are not in the direct contact. And one more important part is that the medium is required. Medium is required. Okay, I'll just write down medium is required. Medium is required. From here, as you can see, what's the medium? This metal rod is the medium through which the heat is traveling from this part to the this part. The metal is, the heat is moving. Clear? Clear, I guess. Okay. Now, based on that, the based on this flow of heat from one region to another region, from basically higher temperature to lower temperature, the materials are categorized into two categories, which are the good conductors of heat and the bad conductors of heat. Okay, by the names only you can understand. Heat energy flows through them easily. It does not allow the heat to pass through them. Okay, best examples are like the silver, copper, aluminium, gold. These are the examples. Okay, most of the metals they allow the heat to pass through them, but still there is an exception. Graphite is a non-metal, but still it is a good conductor of heat. Talking about the bad conductors, so liquid and the gases, they are the bad or the poor conductors of heat. Okay, gases and the liquids are the poor conductors of heat. Especially remember this one, gas are the poor conductor of heat. We will use in the next section when I will teach you the convection. Okay, so how the gases and the liquids get heated, that also we'll try to see. So these are the solids, liquids. Basically, these are the in the solids. When I talk about, let's say glass, okay, wood, okay, clay, asbestos. I don't know what is that. You check it out. Rubber is there, plastics are there, wax are there. These are the bad conductors of heat. Okay, so wax are like when you provide the heat, it will just melt. It will not pass on to another wax. That's why it is the bad conductors of heat. I hope it's clear. I hope it's clear. Okay. Now, next one, let us talk about the application of conductors of heat. Whether it is about the good conductor of heat, let me just remove this one. Okay, whether it is about the good conductor of heat or the bad conductor or the poor conductor of heat, both are having the application in our day-to-day life. Let's say you are cooking something on the oven. Let's say you are cooking something here. Okay, so you want this pan to be conductor of heat so that it can conduct the heat and boil the make the food. It makes the easier to for the food to boil. But this handles you, it is made up of wood. or it is made up of another materials which is a bad conductor of heat, so that it does not reaches your hand. Okay, when you, like the when you're cooking food, we see the spatula. Okay, spatula. So spatula is made up of wood. It made up of PVC. So other materials which is a bad conductor of heat, such that the heat does not reaches your hand. Okay, so that's how that was just a one simple example. From that, there can be a lot of more examples. So practically, whether it is a good conductor of heat or the bad conductor of heat, both are having a practical applications in our day-to-day life. Clear? Acha. Now, next one comes to the in the starting of the chapter, we come across a question which says that the why wool keeps us warm. In the winter season, we prefer to wear the warm clothes. Why do we wear the warm clothes? That we will try to understand from this section. Okay. Generally, what happens? Acha, if I say when you wear the warm clothes, so is the heat generated from the I should not say the warm cloth, whether you better I use the woolen clothes. So when you use the woolen clothes, so is it because of the woolen clothes that it provides the heat? It provides the heat. The heat is generated from the woolen clothes. Is it, or it is something different? Is it something different? So that we will try to understand how the heat is generated. Okay. Now let us here, if you can see, when you wear the woolen clothes, so there is a space between them. In those spaces the air got trapped, like the air molecules got trapped. Now these air molecules are the bad conductor of heat that does not allow the heat to go back. Let's say this is your skin, basically this is your body, this is your skin. Acha, when I was talking about the clinical thermometer, I told no, human body has some temperature. That temperature I forgot to mention. That is around 98 point some Kelvin. Sorry, 98 point something Fahrenheit. This is the body temperature. Okay, which is equivalent to something 36 point something degrees Celsius. So our body is already having temperature. Okay, and when it is cold outside, so what will happen? The temperature, the heat from our body will try to move from from your body to the colder region. To stop that, you wear the woolen clothes. So the trapped air in the woolen clothes, they stop the heat to escape your body, and hence your body remains warm. This is the working. Do you understand? Do you understand? I guess. Okay, so next one we'll talk about the convection. Conduction, I hope it's clear. Nothing is remaining in the conduction. Okay, now talking about the convection. Convection in which convection in this one also medium is required. First of all, in this one also medium is required. But here one difference from conduction. What is the one difference? There is an actual movement of particles. Actual movement of particles are being seen here. Let's say you are trying to boil a water. Okay, well, this is a potassium permanganate. Using this potassium permanganate, actually you can see the movement of particles. That's why it is used. But let's say you take the normal water, you try to boil from the bottom. Okay, so the lower part of the lower particles which are at the bottom of the water, it will get heated up, and when it gets heated up, it expands. Density equals to mass by volume. Okay, acha, whose density is less than water, it sinks. If the density decreases, it starts floating. So at this point, when there is no heat or something, all the water is having the same density. Okay, I'll tell you one thing, whether it is a solid, liquid or gas, except some exceptions, all the objects expands on heating. It expands on it. So when this particle gets expanded, so this volume increases, so density decreases. So due to that reason, it try to go upward. It try to, whenever it heated, it get increased in size, it increase in volume, and density decreases. That's why it try to go upward. This process keeps on happening. The lower part of the water gets heated, it goes up, and the cold water from the top, it try to come down to fill that space, and so on. The water gets heated. As you can see here, what I told, there is actual movement. There is actual movement of the particles that you need to see. There is an actual movement of the particle. Clear? Clear, I guess. Acha. Just let me check the pen. Just give me 1 minute. And is color. Fine. Now, anything else remaining in the convection? So here also medium is required. Okay, here also medium is required, and there is an actual movement of the particles. And this movement from the lower part to another part, that is actually called as the convection current. I'll just write it down. That is convection current. Okay, is that clear? That is called as convection current. So in this one also, medium is required. Well, this is possible in the liquid and gases only. This is not possible in solids. In solids, not possible. Okay, this is possible in the liquid and gases only. Okay, now this convection has a very good application in our day-to-day life. Now let me ask you, When you see, let us try to define the air. Okay, air, the mixture of, mixture of different gases. You can say different. I'm writing in short, mixture of different gases. When you talk about the wind, okay, what do we call wind? Moving air. Moving air is called wind. Wind. But the question comes is how does the air start moving? Okay, so for that question, you'll get the fine answer here. Okay, so there is a two very good phenomena that's called as the sea breeze and the land breeze. Okay, sea breeze happens in the daytime and land breeze happen at the nighttime. Before I explain you this one, let me tell you, when I talk about the water, it's get heated and uh, it's cooled down also. It takes time. But when you talk about the land or the soil, it gets heated or cooled down faster. Okay, first you understand that one. Now, one by one, let us try to understand it with the story. Okay, when the sunlight falls on the water, okay, on the sea, at the same time the sunlight falls on the land also. But what happens? The land has a tendency to get heat up faster, so the air above the land it rises up because of the heat. It gets heated up, it rises up. But the water near the on the the sea, it is still cold. Now, since the air from here it rises up, there is a vacuum created here. To fill that, the air from the sea rushes towards this area. Okay, and this process keeps on going. This rises up, this rushes towards it, this rises up, this rushes towards it. That's called as the sea breeze. That's how the air starts moving. That's how the wind is created. Clear? Clear? That's why in the daytime, when you go near the beach, you feel the cold air coming from the sea. Okay. Next one, talking about the land bridge. At the night time, what happens? The whole day when the sun was, on the water. So because of the sunlight, that water gets heated up. Can you see the color has changed? Okay, just to show you that the water has heated up. It takes time to cool down, but the land gets cooled down fastly. So the air particles here, it rises up, and to fill this one, the cold air from the this horizon, the surface land actually rushes towards the sea. That is called as the sea breeze. The cold air from the land rushes towards the sea. That's called the land breeze. Clear? One thing to notice, and you have to remember that sea breeze always happen in the daytime. Land breeze means nighttime. You can remember like this: sea breeze means the breeze or the wind coming from the sea, which is at the daytime. Land breeze means the breeze or the wind coming from the land. Is that clear? Is that clear? Okay. So I'll give you the notes for this one, or else if you want, you can write down in your own words, or else I'll be giving you the notes for this one. Okay. So let us quickly get back to the third method of the transfer of heat, which is the radiation. Okay. Now, one special thing about the radiation is that it does not require a medium to travel. Okay, you can see it travel in the empty spaces. It can travel in vacuum. It does not require any material medium. Okay, this is the in this form only the heat comes from sun. It reaches from sun to the earth. Why? In between the earth and sun there is no space, there's no nothing, a particle through which the heat can reach here. So basically this heat are in the form of electromagnetic radiation. Electromagnetic radiation, which can travel through vacuum. It can travel through the vacuum. Basically these are the infrared rays that you will read more in the higher classes. These are the infrared rays that does not require a medium to travel. Okay, acha, this infrared rays, it's not just from the sun. Any hot object can generate the infrared rays. Okay, it can come from any place, okay, which is the heat, which is heated. This infrared rays, some amount of infrared rays, it comes for sure. Okay. Now, as I told you, it does not require any medium. It does not require solid, liquid, or gas. It can simply travel through vacuum. Okay, that is clear. Okay. Now, when you talk about the when this radiation are there now, so it get reflected by very polished surface. Acha, why I'm saying that, we will use this concept later on when I'll talk about the thermal flash. So it is reflected by the polished surface, but when it is rough surface, it is absorbed more. Okay, it is absorbed more. So that's all about the radiation. Clear? That is the about the radiation. So here also in the fire, as you can see, the radiation. Acha, one thing I forgot to tell you about the convection. It always, go vertically upward. Is it written here somewhere? It must be written. Language not written. So it is. It always goes vertically upward. Okay. The heat. This part getting heated up. It goes vertically upward. It goes vertically upward. And conduction can go in any direction. Okay. Not in any direction. Basically, it will flow from region of high temperature to low temperature. Talking about the radiation, it can go in any direction. It can go in all the direction. It is free to move in all the direction, and it does not require any medium. Acha. If the medium is there, it's not like it will not move. But that's a plus point for it to that it do not require any medium. Okay, now coming to that question, the questions. I hope the questions are getting clear that I asked in the starting of this session. So the question is like, when why do we wear the light clothes in summer season and the dark clothes in the winter season? Okay, so see, our sunlight is made up of electromagnetic spectrum. I'll just remove this one completely. Okay, so it is made up of electromagnetic spectrum. Now, when I talk about the electromagnetic spectrum, let us not talk completely. Let us talk about the visible light. Visible light. So it is what from Vibgyor, Vgyor. It starts from violet, okay, and all the way go till red. So how do you able to see that? Let's say this is the white screen. How are you able to see this? Because it is reflecting, or let's say since it is led, or if you are using in your phone, so that is led. But let's say if you see the color of your paper, notebook, you see the white color. How do you see the white color? Because all the lights getting reflected and coming to your eyes. Acha, that's how we see the objects basically. The lights getting reflected from some place and it is coming to our eyes. Let's say if I see the red color here, red color from here, or let's say we see the red color or any blue color. So the reason is this whole color is coming to it. Okay, all other colors are absorbed, only red color is reflected. That's what we see in our eyes. That's why we see the red color. So when all the colors are reflected back, then we see the white color ideally. And when none of the color are reflected, like all the colors are absorbed, then we see the black color. Now you can understand this one. In the summer days, because of the light clothes, what happens? It reflects almost most of the light backward. That's why the temperature of the body remains normal. But in the same sunlight, you go out with a black t-shirt on. Okay, what it will do? It will absorb all the spectrum. It will absorb all the visible light. Because of that, it will catch the more amount of heat. Okay, and you find it uncomfortable to wear this. That's why in the winter days we wish to wear the dark clothes, and in the summer days we wish to wear the light colored clothes. I hope that's clear, I guess. Okay, if you're not clear, again, this is a good thing about watching the videos. You can go back to the videos again and try to see the things, try to think upon the things again. You can replay it again, you can make it slow, you can try to understand, you can stop me. Okay, you can stop me somewhere that, okay sir, let me try, think, let me think. So you can stop me and see at your own pace, that at your own level. Okay. Okay. Is it feeling odd or is it fine? Like, because I have, removed my webcam because it was, taking some of the content. Like, if this one is there, so this much area was being taken by the webcam, so you could not see these content. So that's why I removed it. But I guess I'm able to communicate in the better way so that you can understand. Okay, I hope I'm able to communicate. Okay, let's say for an example, this conduction, convection, and radiation. One best example, let's say there is a burner here. So this radiation is coming like this one. Convection is like this one, which goes outside, and conduction is like exactly in the contact, in the direct contact. That is because of the conduction. One more, I have some one picture I can show you. Wait. Hide presenter. Just one moment. Let me take that picture. I don't know whether I'll be able to take that picture or not. I'll just try. Hmm. Okay. I hope. Oh no, I'm not able to take that picture. Let it be. Let's say, okay, this one I can explain. Let's say on the gas, so the heat from the gas, it is coming to the kettle because of conduction, and the water is rising up because of convection, and this heat is going in another directions. That is called because of the radiation. Acha, because of this reason only, the top roof of your any home or in the factories, you see the rooftops are, first of all, it is made up of shiny objects. First thing, also it is painted white so that it reflects most of the heat coming from it. Okay, Same is with the case of this one also, the heat goes up and comes back. So hence the heat is trapped inside for longer time. How we can trap it for more time? Acha, let's have, before going into that, let us have a quick discussion about whatever the difference between conduction, convection, and radiation that we have seen as of now. In conduction, medium is required. In convection, medium is required, and radiation, no medium is required. Conduction is done in solids only. Convection in liquids only. It can travel in vacuum. It does not require solid, liquid, gas, or whatever it is. In conduction, there is no actual movement of particle. In convection, it is actual movement of particle. In radiation, there is no particles needed. Particles चाहिए ही नहीं, ठीक है? And examples, there's a frying pan, there's a boiling water, and heat from the sun. These are some of the examples that's easy that we have discussed already. I guess it's clear. Okay. Now this one, I'm not explaining anything. This is the same thing I've explained. See, like that. This is the example of very, very famous Himalayan Bukhari. So there's a fire in this one because of the heat. This pan is getting heated because of the conduction. This water coming out because of convection, and this heat going in this direction because of radiation. Okay, so this setup is used in the the Uttarakhand region and the Kashmir, Jammu and Kashmir region where the cold is high. So what happens at the same time they can cook the food also, and this because of this radiation that their home also remain hot. Clear? So this is a very good example. It's a kind of it's a masterpiece of science that they use in their daily life. Acha, we are on to the last section of our discussion. Let us talk about the thermos flask. Okay. Acha, you may think like this chapter is getting bigger because the concepts are like that. There are many concepts. I just tried covering all of them, and we are on to the last part of it. Okay. So let us talk about the thermos flask. So in the starting, I also asked you one question. Ki when I talk about the thermos flask, what is the how the water remains hot for longer time. Acha, when we talk about the heat transfer, so there are three methods in which the heat can be transferred. First one is the conduction. Okay. Next one, convection, and the last one is the radiation. Acha, for the heat to not pass from this bottle to outside, what we have to do, we have to stop all of them. Acha, first let us talk about the conduction. For conduction, what we do, for conduction happens only when it is in direct contact, first thing. Second one, conduction can happen only through the good conductors of heat. So let's say if you keep water in some flask which is the bad conductor of heat, let's say the glass, then water, the heat cannot escape. So first one is cleared. Okay. Next one, talk about the convection. Convection can, it can rises up, the water can rises up and go up from the top. So what you do, from the top also you seal tight it. Okay, you seal tight it completely so that no temperature can escape. You seal tight with the bad conductor of heat. So convection also done. Talking about the radiation, radiation does not require any medium, but we know that if this is the polished surface, so if the radiation is going like this one, it will again reflected in the same medium. So that's what we do in the thermos flask. If you see, the outer part is made up of shining steel surface. So what does it do? If the water is coming, the heat trying to go from here, so it just reflected back in the water again. If try to go, it just reflected back in the same water. Also, that is the double layer. So this is a silver lining in the outer surface which prevents the radiation. Okay, that is a double glass layer which prevents the conduction and convection. Okay, these are the things. Still, let's say after 20 or 22 hours, the water gets cooler because even though it is reflecting but not reflecting completely, so because of radiation, some of the heat gets goes out of the bottle. But that process is very slow. So that's why it is a good application where we restrict the conduction, convection, and radiation, and we can use that bottle to keep the water warm for longer time, or to keep the anything cold for longer time also. Clear? So how do we do it? We stop the conduction. So basically the vacuum between the double glass wall. Achha, this one you read by yourself. That's the same thing I explained. You just see, you stop the video, you pause the video, you read it out again. Okay, and that's the same thing I explained. Achha. Before ending this chapter, I'll just quickly like to tell you about the change of state. Okay, change of state. Whether you talk about the changing from gas to solid. Okay, let us write down. Let's say the gas, this is a liquid, and this is solid. So when you convert gas to liquid, okay, so you have to do the condensation, and from liquid to gas, when you have to do, so what you do evaporation. When you go from liquid to solid, what you do the freezing. That process is called as the freezing. From solid to liquid, it is the melting. Okay, from gas to solid, if you go, that's called a deposition. From solid to directly gas, that is called as a sublimation. That is called as sublimation. Acha, if you try to observe carefully, you will realize that all these processes are basically the exchange of energy, heat energy. How? From solid, if it leaves some heat energy, it will convert to liquid. If liquid leaves some heat energy, it converts to gas. If the gas is okay, gets some heat energy. Sorry, it sorry, when the gas is release some energy, it converts to liquid. Okay, and the liquid release some energy, it again gets to convert to solid. Okay, did I say opposite, ulta क्या? Again, अगर ठीक है मैं फिर से बोल देता हूँ. Solids, if it take some heat, sorry, मैं लास्ट टाइम लगता है मैं उल्टा बोल दिया. It takes some heat. अगर तुम इसको हीट देते हो तो ये कन्वर्ट करेगा लिक्विड में. लिक्विड को फिर थोड़ा सा हीट दो, इट कन्वर्ट्स टू गैस. अगर ये गैस हीट को एस्केप करता है तो ये कन्वर्ट होगा लिक्विड में. अगर लिक्विड गैस को हीट को एस्केप करता है, ये कन्वर्ट होगा सॉलिड में. सिमिलरली गैस अगर जो है हीट को एस्केप करता है, छोड़ता है, then it converts to solid, back to solid. So in all these processes, the temperature, the change in it is because of the change in temperature. Clear, I guess. Acha. Let us quickly talk about the applications of heat. Okay, what are the applications? I say बहुत सारे applications we have already seen in this chapter only, but there's a lot applications of heat, like in the iron box. Okay, like the cooking, woolen clothes are there, poly surface like the thermos flask are there, so had land breeze and sea breeze. So there's a lot of real life applications that we have seen in this chapter. Okay, clear. Okay, now here I guess we end our chapter. Let us quickly recap. So we discussed about the radiation, convection, conduction, and the flow of heat, which is from the hot to cold object. Some some summary points, note points. 1 calorie is basically the sorry, 1 kilocalorie is equals to 1,000 calories. Okay, and the SI unit is joule, where 1 calorie is equals to 4.186 joule. Good conductors are basically which will allow the heat to pass through them easily. Bad conductor means the objects which does not allow the heat to pass through them easily. Talking about the radiation, heat radiation, so it travels at the speed of light. Acha, this one I forgot to tell you. The radiation speed travels at the speed of light and in the straight line like this one, and can travel through the vacuum that I told you. Thermos flask principle: vacuum is created and the stopper is there and the silver wad is there, which prevents the conduction, convection, and the radiation. Clear, I guess. Acha. Why are cooking utensils are made up of metal, copper, steel? Because they are the good conductor of heat. Because they are the good conductors of heat. Next one. If you wrap an ice cube in an aluminum foil versus thick woolen cloth, which one will melt faster? Why? Think about the good and the bad conductors. See, if you wrap an ice cube in the woolen clothes, it will take time to melt because the heat cannot reaches the ice to melt it. Okay, but if you wrap in the aluminum foil, but aluminum is a good conductor of heat, so the heat from the outside will reaches the ice cube and it will melt faster. Talking about the next question, it is saying that you are standing on a bench during a hot summer day in the wind blowing from the land to the sea. Is the sea or the sea to the land? You are standing on the bench during a hot summer day, daytime. So daytime, do you remember? Daytime it is. I'll show you again. This यहाँ पे हम अक्सर बच्चे कंफ्यूज करते हैं. See, in the daytime it is the sea breeze. मतलब कि ये sea से land की तरफ से आ रहा होगा. Clear है? ठीक है. Now, next one. ये कुछ क्वेश्चंस है that you try to see by yourself and try to answer by yourself. अगर कुछ समझ में नहीं आता, you can put it out in the comment section or anything. You can just post it here. I'm leaving these questions for you. बहुत simple है, easy है. Okay, like the if you see here, which of the following is a non-metal but a good conductor of heat? So graphite, I told na. The heat from the sun reaches the earth by the which process? By the radiation. Why are the bottoms of the cooking utensils are often painted black? Because black absorbs heat rapidly. Okay. Acha, this one, why does a metal spoon feel hotter than a wooden spoon when kept in the hot tea? Achha, these questions you try to do it by yourself. These are some questions I'm just leaving on you. Most of them are the theoretical questions. Some of them are the numerical questions. Like this one is the numerical question. Why are food values written in kilocalories? Okay, why are the cooking utensils are made up of metal? So these things you try to do it. There's no question that you cannot do. If you're not able to do it, you can just post it here. So this is everything I have explained. Why do we wear the white clothes in summer days? Why are air conditioners installed near the ceiling? Because at the ceiling, the higher they see the hot air rises up. So the air conditioners take that hot air from the room. Now next one, let us talk about the journey of water. अच्छा बात करें जो हमारी पिछली किताबें थी NCERT की. In that one, this topic was not there in the new textbook. This topic is introduced. So yeah, we'll read about this one. Talking about the water. So this is we are having water in the three forms: in the solid state, in the liquid state, and in the gaseous state. The water that can be used by us in our day-to-day life, the day-to-day life application, is the water in a liquid form. Now, in the liquid form also, most of the water is the saline water, which is present in the ocean, in the sea, that is not useful for us. The water which is the fresh water in the sea, in the groundwater, that is useful for us. Okay, so basically in this chapter we'll try to understand the water cycle. Okay, we'll try to understand how the water seeps underground, how when it rains, or how does the water goes inside the underground, and from where the underground water is coming. How the underground water is recharged. Okay, we'll try to explore the hidden aquifers, like when the water, if you see on the top, you cannot use it directly, but that the same water when it comes up, it is fresh. You can use it directly. Okay, and we'll discover some of the amazing water conservation techniques. Okay, clear, clear. Okay, now this is some of the historical facts that you can see. So in the 6th century, basically, Ujjaini, he used to predict the seasonal rainfall by studying the cloud formation, winter patterns, and the starts. That we can do actually by seeing the patterns. That's how the scientists work. That's the working. That's not the this is not the some religious things or something. It is basically the scientific method. You observe the pattern and you try to find out some conclusion. That's what the scientific method talk about. Remember the first chapter, right? So let us first of all let us talk about the water cycles. What happens due to the sunlight? This water gets heated up. The upper layer gets evaporated. It evaporates and goes up. When it goes up, there the temperature drops. Because of that drop in the temperature, it converts to the water droplets. These water droplets, that's acquired. This is smaller, then it keep on getting bigger, bigger, bigger. When it goes to the some region where the temperature is become higher, because this become bigger, it eventually comes down a little down. When it comes down, it becomes heated up, and it drops down again in the form of water, in the form of rain, that we see it as a that we see that we call as a rain. That rain again collected in the river waters, and that river water again goes to the sea. So there is a complete cycle. That's why we call it as a water cycle. Okay, so when you have to define the what is the water cycle, so you can simply say that it is the continuous movement of the water upward and the vapor downwards, the precipitation passing through land and the plants, and returning back to the water bodies like the ocean, seas, and like that. Clear? Is this clear? Acha, talking about the investigate, the water moves through the soil. When the water from the ground, okay, from the rain, when it reaches, how does it reaches the ground level? So because in the ground there are different kinds of particles. There's like bigger particles, then even more smaller particles, and even more smaller particles. So passing through all of these particles, at the end the water become very clear and very pure. Okay, because of that become very pure. You can see from here, let's say the water, it's raining, and the groundwater, it seeps downwards. When it seeps downward, because the dust particles, or the particles which is unnecessary, or not which makes the water dirty, so those dirt particles just remain in these areas only, and the pure water reaches and seeps down and remains here as a groundwater, or table water also we call sometimes. So these table waters, using the hand pump or in the motor, you can take it down again. The good thing about this groundwater, that when you take it outside, it is in the pure form. Because of this CPS, the dust particles just just remain there. So the water you get from here is the pure. You can use it directly. Clear. So talking about the infiltration, basically it is the surface water seeping through the soil and rocks. Talking about the groundwater, so it is the water stored in the pores spaces and beneath the surface. And talking about aquifer, it is the underground layer of the rocks and sediments and the storing groundwaters. Okay, talking about the infiltration, so you can see from here also aquifer, and the groundwater, basically the stored water inside the tiny pores or spaces in the sediments. Clear. Okay. Acha, because of the high demand of water, this ground level is going down. Okay, and also because of the decreased vegetation, increase in the population. Because of increased population, what happens? There's a lot of roads now, and the cemented area is more. So that cemented area stops the water to recharge the ground level. Okay, it does not. It could not reach the the ground. Because of that, the ground level, the water level of the ground stops. It does not recharge again. So these are some of the things. Can you see here? The concrete surfaces in the cities block the infiltration. But the water cannot go inside the surface of the soil. So because of these reasons, the water table, okay, the groundwater level is decreasing. What is the solution? What is the solution? There's a one best method is the rainwater harvesting. Rainwater harvesting is basically, it is the is a one process to recharge the groundwater. Okay, on rainwater, what does it do? You can collect the rainwater and put it into the you can store in a tank, because rainwater is the purest form of purest form of water. Okay, it is a pure form of water, so you can store it into the tank or somewhere, and you can use it later for different purposes. Okay, clear? Acha, I'd like to talk a little bit about one problem. Mostly, this discovery, I would like to take very respectfully the person named Sonam Wangchuk. Okay, Mr. Sonam Wangchuk. So he discovered this one. Okay, he discovered this. He got the idea of the ice stupa. So what used to happen, mostly in the Ladakh region, or especially the region where there is a very cold region in the winter season. So in the cold region, the water, what it used to have, the water used to freeze, and in the summer days there is a lack of water. Okay, suddenly all the water goes slow off. Okay, so what does he do? He came up with the innovation. He did a sprinkler system. Because of that sprinkle, the water used to sprinkle, and because of the lower temperature, the water used to store. Water used to store. So it used to create. This is called the ice stupa, which is made human made. And in the summer days, it used to melt slowly. It used to melt slowly. Because of that, the water problem in that area, it got resolved. The water shortage got resolved. Clear. So that was one of the very great innovation in my opinion. Now talking about, let's talk about some of the MCQ type questions. Which material allow the water to seep through it faster? So it will be sand, I guess. What is the main difference between evaporation and transpiration? That is a different thing. Acha, let us some of the true false question, the concept check. These are the questions that you can try to do it by yourself. And yes, here we complete our chapter. So this chapter is also over. Again, if there's any doubt, any question is there, you can just post it here, and we will come back again with some another chapter. Okay, and next chapter, I guess it is the motion and the time measurement. Mostly it is dedicated to that, so I'm working on that. Soon I'll come with that lecture also. Okay, so till here I hope it's clear. Okay, so let us end our class. Thank you so much.